In this lesson, we take a look at the ambient occlusion and the curvature shader. For this lesson, I have this toy truck model and also this sculpture that we're going to be using it later on. But for now, let me hide that and unhide the track model that we have here. Now let's create a new Arnold Shader Network editor and assign it to our truck. And let me search for ambient occlusion and drag it to the work area. Ambient occlusion allows you to approximately fake or simulate global illumination or indirect diffuse lighting. Back in the time when using global illumination was very expensive and would take forever to render, artists would use ambient occlusion to simulate global illumination without having to use the full solution. But nowadays, the main use of ambient occlusion is to add a bit more detail to the render by multiplying the ambient occlusion pass over the beauty render pass, which we'll learn how to do it when we discuss AOVs in the rendering section of this course, or to add dirt, for example, to the corners and nooks and crannies in your render. You can see in this render, based on how the surfaces are put together and how they interact with each other, we have very bright areas and very dark areas. So we have this white color, which controls the color of the unoccluded areas. Let's use probably a blue color. And we have the black color, which controls the color of the occluded areas. Let's use a red color for the black color here. We have sample, which controls the number of samples we want to calculate ambient occlusion. The higher the number, the less noisy the effect would be. So at 0, as you can see, we get basically no ambient occlusion, only the white color is apparent here. And if I increase it to something like 1, you can see we get this grainy and noisy effect. And if I obviously increase it to something like 5, now we have a much cleaner result. We have spread, which controls how focused or diffused ambient occlusion should be. So as I am decreasing this value, basically I'm compressing the effect and increasing the contrast between occluded and unoccluded area. So let's try something like 0.5, 0.3, 0.1. And at 0, we only have two distinguished colors, which are the black and the white color. And there is no gradation between occluded and unoccluded areas. Let me set the spread back to 1 and the samples back to 3. Then we have this near clip value, which is the minimum occlusion distance that is sampled. So as I increase the near clip to, let's say, something like 0.5, you start to see less detail in the corners and crevices, and this is exactly what near clip is for. We have far clip, which is the maximum occlusion distance that is sampled. So as I start to decrease it to something, let's say like 0.5 or even 0.3 or 0.1, we start to lose ambient occlusion in the broader areas. So you can decrease this value in case you are interested in the very fine details. Then we have fall off, which controls how the effect gradates between occluded and unoccluded areas. And as I start to increase it to something like 1, 5, let me actually set the far clip back to 100. So as I increase the fall off to something like 1, 5, or even 10, you can see how the effect is being limited to just the very corners. Then we have this inverse normal, which solid angle defines this option like this. This attribute changes the direction of the rays being traced. When it is off, the rays are traced outside of the surface. When it is on, the rays are traced inside the surface. I can loosely say that it inverts the ambient occlusion effect if I enable the invert normal. And we have this self-only option, which, if enabled, the shader only gathers occlusion against the same object. So basically it won't consider other objects when calculating the ambient occlusion effect. In this case, if I zero out the fall off and turn off the self only, you can see this is the effect that we have when self only is off. And if I enable this, Right now this is the effect that we get because at this time the floor geometry won't be considered for the ambient occlusion effect and the object only take a look at its own geometry. Let me just turn off self only and use a white color for the white and use obviously black color for the black color. Now you can use this ambient occlusion like any other black and white map. For example, you can connect it to the base color or the specular weight of a standard surface shader. So if I just create, let's say, a standard surface shader, I can use this ambient occlusion, let's say, as the specular color or specular weight, and connect that here. Now what's gonna happen, these parts, these nooks and crannies that are black in our ambient occlusion are gonna have a weight of 0, therefore they are not gonna have any specular reflections in those parts, and the other parts which are gonna get the white colors of the ambient occlusion, therefore having the weight value of 1, are gonna be more reflective. Okay, let me delete this, and for now we can actually connect this. And now let me just hide this track model and unhide this sculpture here. Now let's create another shader network, and this time let's look for the curvature, which is under surface again, and let's assign this to R and run the IPR. Now, curvature is a map that outputs black and white based on the concave and convex areas of the geometry. So you can see by default in the curvature map, the output is set to convex. So you can see convex areas of this object are mapped white and the rest of the model has darker grayscale values. We can change the output to concave, and the opposite is happening. The concave areas are white and the convex areas are black. Another output mode here is both. In this mode, the output of the convex areas will be in the red channel and concave areas in the green channel. For now, let's set this to convex, and let's probably decrease the radius to something like 0.05 for now. We have up here samples, which controls the overall quality of the curvature sampling, and higher values will result in less noise, obviously. We have radius, which controls the overall radius of the effect, and smaller values will result in finer detail, and higher values would make the effect smoother. In this case, let's try something like 0.02 maybe. Now we get more detail, and if I increase it to something like 0.2, or maybe 0.15, we get less detail. In this case, probably something like 0.05 would be enough. We have spread, and decreasing this value will result in a more restricted effect. Lower values of spread will shoot rays more vertically with respect to the surface, and the default value of 1 means that rays are shot in all directions. This acts as a threshold to remove unwanted small variations of the curvature. Maybe let's try something like, this was 0.05 here. Let's try something like 0.75, maybe 0.85. As you can see, the spread affects the overall curvature look. Let me set the spread back to 1. We have threshold, and it considers only curvature above the normalized angle with 0 to 1 mapping to 0 to 180 degrees. We have bias, and the bias will affect the fall off of the curvature, and higher values here like 0.88 will cover more and exaggerate the curvature, while smaller values will emphasize small details. If I try something like 0.26, Let me set this to 0.5 again. And we have multiply, which multiplies the overall curvature effect by the factor you specify here. For example, if I set the multiply to something like 2, we get a stronger effect, and if I set it to something like 0.5, we get weaker effect compared to before. Now, the way you use this shader practically is very obvious. You have black and white output from your curvature map, and you can use this map in your network shader however you want. For example, if you connect the output of the curvature shader to the specular weight of your shader, the white parts are going to be more reflective and the darker parts are going to be less reflective. If you go to our website, mographplus.com, or our YouTube channel, we have a free tutorial called Creating Iron Man Suit Shaders in Arnold for Cinema 4D. It's a very long and free tutorial, and there I use the curvature shader a few times to create some very realistic shaders. In this case, let me set the multiply back to 1, and the multiply is actually the value that you use if you want to break the effect. So if I set the radius to, let's say, something like 0.03, and let me just load an image here and drag it on top of the curvature shader, and let's probably use this one and connect it to the multiply input. And as you can see, what it does, it basically breaks the effect. Let me just make sure it's okay. That's the place we can actually use the triplanar. So let's input and use this as the multiply here and connect the curvature, Alt W V. Now as you can see how this texture is basically breaking the curvature, right? So it's multiplying the effect. So where the texture is white, we're going to get a more stronger curvature effect, and where the texture is black, we're going to be cutting the curvature effect. Okay, let me just hide this, and I'm going to use something like 0.02 and probably a multiplier of like 1.5. Now I can use this, let's say if I have a standard shader, okay, sorry, standard surface shader, and connect it here. Now let's say we want to use this as the metalness controller. So if I go to the metalness here, now as you can see where the curvature map is white, we get this metallic look, and where the curvature map is black, now the curvature map is obviously controlling the metalness value here, and where the curvature map is black, we obviously getting the kind of plastic look that the standard surface provides. Okay folks, so that's about the ambient occlusion and the curvature shader in Arnold for Cinema 4D. See you in the next lesson to continue with the shading section of the course. See you there.